The topic is disjoint sets. In this video, I will cover the following things. First is what are disjoint sets and the operations on them. Then detecting a cycle. See, disjoint sets are useful for detecting a cycle in non-directed graph or undirected graph. So we will take an example and learn how to detect a cycle in a non-directed graph. Then graphically how to represent these disjoint sets and how it can be represented using array. And lastly, the time efficient operations on disjoint sets are weighted union and collapsing find that are based on the ranks or weights. We will see that. Disjoint sets are similar to sets topic in mathematics, but not exactly. They are a little bit changed for making them useful in algorithms. So the famous algorithm that uses disjoint set is Kruskal's algorithm, which detects a cycle in a graph. So let us see how these disjoint sets are different from normal sets of mathematics. Let us understand what are disjoint sets. See, here I have a non-connected and non-directed graph. There are two components. It's not connected graph. Two components I have taken. And each component I have represented it as a set. Set S1 is having 1, 2, 3, 4. These are the vertices of this component. And set 2 is having 5, 6, 7, 8. These are the vertices of second component. So the two different components are representing two different sets. And what is a disjoint here? So no vertex is common here. The numbers are not common here. So if you take intersection of these two, S1 and S2, then you will not get anything. 5, empty set. So that is disjoint. Disjoint set means two sets are not having anything common. Then how we use them? What are the operations on them? See, we prefer performing only two operations, that are find and union. I'll show what does it mean by these operations. So first operation, find. I want to know vertex 5 belongs to which set? It's not here. Yeah, it's here. So it belongs to set 2. Find operation is to find out any element or a vertex belonging to which set. It's like a set membership operation also. Means that element is member of which set. So like I want to find out 7. 7 doesn't belong here. Okay, here it belongs. So it belongs to set 2. Then 3. Find 3. Find 3. Where it is? Here. So it is set 1. So that's it. Find operation is very simple. So you have to find out in which set it belongs to. So I am showing you just mathematically. Later we will come to the data structure. Now let us look at union operation. See, for showing you union operation, I'll try to connect these two with an edge. I have added this edge, that is 4 to 8. So when you add an edge, then what we do here is we perform union operation. So we connected what? 4, 8 we have connected. Now find 4. 4, yeah, it belongs to set 1. Find 8. 8, yeah, here it belongs. So it is in set 2. So find 4 and find 8. They belong to two different sets. So perform union, S1 union S2. So now we get a set that is 1, 2, 3, 4, 5, 6, 7, 8. This is union operation. See, in mathematics simply we perform union on two sets. But here there is a reason of performing union. What is the reason? If there is an edge u comma v, find out u to which set it belongs and find out v to which set it belongs, and if they belong to different sets, then perform union of those two sets. This is the purpose of performing union. Now why we are doing this? Let us see next. I'll add one more edge, 1 to 5. So this is 1 to 5. Now we don't have these sets that are union and we got a new set. Let us call this as set 3. So we have a new set. Those elements are gone. This is the final set. Now 1, 5. 1. Yes. Find 1. It's present here. Find 5. Yes, it is present here. Now both these vertices or numbers are belonging to same set. And if they belong to same set means there is a cycle. That's it. This is the way we find out a cycle in a graph. So what are the things we learned? What is find operation, what is union operation, and what is the purpose of union operation? Then how we can know that there is a cycle in a graph. If you take any edge and both the vertices are belonging to same set, then there is a cycle in a graph. So this was a very simple example. I have shown you what does it mean by find and union. Now we will take one example graph and we will see from the beginning how we can detect a cycle in a graph. I will form all the sets right from the beginning. I will add all the edges one by one. Let us take an example and find out how we can find a cycle, how we can detect a cycle in a graph with the help of disjoint sets. Here I have taken one example graph, and in this I have labeled the vertices. So let us say these are some weights. So just like let us find a minimum cost spanning tree from this one. Otherwise you can also say that I have numbered them. So first edge that I'll be taking is this one, then this one, second one, then third and fourth. In this way I will include all the edges of a graph. Now how we can take the help of disjoint sets for finding a cycle? Let us check. See, there are 8 vertices. I have taken a universal set with 8 vertices. Each element you consider it as a set. Now let us start. What we'll be doing is we'll be going on taking edges, including edges and forming the sets for them one by one. So the first edge is 1, 2. So the first edge is 1, 2. So find 1, 1 is here. And find 2, it is here. So actually they are in universal set. So form a set for them, take 1 and 2. So perform union on 1 and 2. So from this universal set they are removed and they are brought into set 1, S1. Now next edge is 3, 4. So 3, 4. 3 is in universal set, remove this. Find 4, this is in this universal set, remove it. So form a set that is set 2 with 3 and 4. Then third edge 5, 6. So this is 5, 6 and they belong to universal set. Remove them from there and form a set for them 5, 6. The next one is fourth edge is 7, 8. So take 7 and 8 and find 7, it is here. Find 8, it is here. They are in universal set. Form a set for them, that is 7 and 8. Now the next edge after the fourth edge, this is the fifth edge I am going to take, that is 2, 4. Now you can see that all these vertices are removed, numbers are removed, they are in different sets now. Now find 2, it's not there, just forget this one. Find 2, it is here. Find 4, it is here. So they are in 2 different sets. Perform union. So I will form a new set, that is set 5, by taking union of these 2, 1, 2, 3, 4. I have performed union on these 2 sets. So now you can see that union is being performed. Let us go to our next edge. After 2, 4, this one 2, 4, sixth one is this one, that is 2, 5. So 2, 5. Find 2. So 2 is in this set. Now these are union. Remove them. This is in set 5 and 5 is in set 3. Perform union of these 2 and form a set 6. So what are those vertices? 1, 2, 3, 4 and these 2, 5, 6. See, the reason of performing union is we are including an edge, considering an edge. So this set is also gone. We have a union. This is also gone. Now we have only 2 sets now. Right? Now after this edge, 7th edge is this one, 1, 3. 1, 3. I'll remove these sets and I'll just write 2 sets here. Find 1, it belongs to set 6. Find 3, it belongs to same set. So when they both belong to same set, it means there is a cycle. Yes, you can see that by taking this edge, I'll be forming cycle. I will highlight the edges that I have included so far. See, I have included these edges. I have included these. I have included these edges. Right? Now if I include this edge, this will form a cycle. So don't include this. That's how the edge which is forming a cycle, don't include it. We have detected one cycle. Let us continue. After that 7th edge, the next edge, 8th one is this one. So 8 is what? 6 and 8. 6 and 8. Let us see, find 6. Find 6. 6 belongs here. Find 8. 8 belongs to this one. So they are in different sets. Perform union. Now we'll get 7th set. And what is that? 1, 2, 3, 4, 5, 6 from this set. And 7, 8 from this set. 7 and 8 from this set. So these two are gone. So this is also included. Now the last edge remaining is 9th one. 5 comma 7. 5 comma 7. Find 5. It is in this set. Find 7. This is also in this set. Both all are in same set only now. As they both belong to same set, there is a cycle. So this is how Kruskal algorithm also uses it in the same way for finding a spanning tree. Like you may be knowing that in Kruskal's algorithm always we select a minimum cost edge. Now shall we select it or not? Is it forming a cycle or not? How we can know? By checking into the sets. So this was like a working of Kruskal's algorithm only. Now how it is done graphically and how it is represented using array, that we have to see. So I'll take the same graph and show you. Let us quickly look at how we can show the sets graphically. So I will do the same thing. I have the same graph and the vertices. These, instead of universal set, I have shown them as vertices here. That is, I have taken notes. Now I will go on including the edges. So the first edge is 1, 2. If I include edge 1, 2, you remember I was making a set as 1, 2. Now actually we don't need a set. We are not performing mathematical operations here like intersection, union, difference. We are not performing that one. So what we want is just we want to detect a cycle. So we want to do it in an easy way. So instead of showing it like this graphically, we will take 1 and 2. Basically, we don't need the name of a set. We need just one representative of a set. So we will make vertex 1 as a parent of set and 2 as a child. If you like, you can make 2 as a parent and 1 as a child also. So let me show you other edges, that is 3, 4. So if I take 3, 4 and make a set 3, 4. So 3 as a parent and 4 as a child of it. Now third set, that is 5, 6 child. Then set 4, 7, 8. I have included 4 edges. I got 4 set. Graphically they are shown like this. Now let me include the next one. From here you can get the clear picture. Edge 2, 4. Fifth one, 2, 4. So where is 2? 2 is here. Who is the parent of 2? 1. The next is 4. Find 4. 4 is here. Who is the parent of 4? 3. So these are in 2 different sets. So you remember we perform union. How to perform union? So we'll select 1 as a parent and 2 as a child here. And its child is a 3 and 4. So we made the parent of one set as a child of the parent of another set. So you may be asking that why didn't you select a 3 as a parent? If you want, you select that one also. It makes no difference. It makes no difference. Whether you take 3 as a parent and 1 you make it as a child of 3, it makes no difference. Then next one, after 5th, 6th one is a 2, 5. 2 is here. Who is the parent of this one? 1. Then 5 is here. So they are in 2 different sets. These are in 2 different sets. So we'll include that. 5 we will bring it here and 6 here. Actually these are gone. I'll remove them. Now again one more thing. Here also you can ask a question, why didn't you select 5 as a parent? See, here I have a strong answer that before including this, see how many nodes are there? 4 nodes are there. So weight of this set is more and this weight is less. So we will make this as a parent and this as child. Earlier, although both the sets were having the same number of elements, but now this set 1, 2, 3, 4 is having more number of elements. 5, 6 is having just 2 elements. So this is representing this set, you see. 1, 2, 3, 4, 5, 6. This is 5th, 6th set. If you remember, already we have done this. So now this is gone. Now next is 7th one, 1, 3. 1, 3. 1 is the parent itself and 3, its parent is 1. So both of their parent is 1 only, it is 1 only, so they belong to set 1, so both belong to same set, so it's a cycle. That's enough, I will not go further. So this is how we detect whether there is a cycle or not. Graphically I have shown you. Now let us see the same thing again with the help of an array. How it is done using array. Now I'll show you the graphical representation as well as array representation. See, for representing a set we don't need the name of a set. We are not performing actual union, intersection or set difference operations of mathematics. We just want to perform find and union. Our objective is to detect a cycle. So for that, for all 8 vertices we will take a single array called parent, and the indices are representing these 8 vertices, and each is having value -1, means each vertex is in its own set. Next, to show you graphically how it looks like, I have even taken these 8 nodes. Now let us perform the same thing on this graph and see how we will represent sets in an array, and also I will show it graphically. So first edge 1, 2. 1, 2. 1. Who is the parent of 1? -1. Itself. 2. Find 2. Go to index 2 and see what is there. -1. So who is the parent of 2? Itself. So how much time it has taken for finding 1 and finding 2? Find 1, it's -1. Find 2, it's -1. So constant time. So they belong to 2 different sets. Now perform union. How we perform union? So graphically I will show. I will select 1 as a parent and 2 as a child. So 2 is a child of 1. So here we will write 1. So who is the parent of 2 now? 1. And what is 1? -1. So there is a parent. So if there is -1 or negative value, then it's a parent. Now I'll do one more thing. Total how many nodes are there? 2 nodes are there. So instead of writing just -1, I'll write negative only. So -2. So there are 2 things. Minus shows that it's a parent and 2 shows that there are 2 nodes here. That's it. Let us continue, repeat the same thing for all of them. Next edge is 3, 4. 3, 4. Find 3, -1. Itself is a parent. 4, -1. Itself is a parent. So form a set. So who is the parent of 4? 3. And what is a 3? It's parent. But there are 2 nodes in this one. 5, 6, third one. So find 5. This is -1. Find 6, -1. So 5 here and 6 here. So this is 5 and this is -2. Now the next edge is this one, 7, 8. Find 7, itself is a parent. Find 8, itself is a parent. Now make 8 as a child of this 7, or 7 as a parent. So this is 7 and this is 2. Till here we have finished. Next, fifth edge, 2, 4. Sorry, 2, 4. Find 2, 1 is a parent. Find 4, 3 is a parent. Let us do it in an array. 2, go to 2, 1. Go to 1, -2. So who is the parent of this one? 1. Find 4, go to 4, 3. Go to 3, -2. So who is the parent of this one? 3. And this was 1. They are different parent. Perform union. So whom we should select as a parent? 1 we will select it as parent. So at a 3, I will write 1. Then total how many nodes now? 4 nodes. So graphically, 3 will come as a child of 1 and here is 4. That's it. So that's how union is done. Now let us take next one. Fifth. Now this is sixth. 2, 5. 2 and 5. Let us see who is the parent of 2. 1. Let us look at here. 2. It's 1. Go to 1. It's -4. Just one step we are going, right? It's not n time. We consider it as constant time only. Find 5. 5. Go to 5. -2. Itself is a parent. So for 2, this is a parent. And for 5, itself is a parent. Now who should become the parent for both? We have to perform union now. Unite these two. So who should become parent? 1 or 5? See, what is there at 1? minus 4. What is there at 5? Minus 2. Whose weight is greater? Rank is greater. Weight or rank, both are same, only here we call it as rank also. Whose rank is greater? 1's rank is greater. So let 5 come as a child of 1. So at 5 we write 1. Now 2 more nodes are added to this. So 4 and that minus 2 is added. So it becomes, 2 more nodes are added to it. That 4 and minus 2, it becomes 6. So total 6 nodes are here. This is how union is performed. Let us go to next one. After 6, 7th. 7th is what? 7th is 1, 3. This will be interesting. Find 1. 1. Okay, here in this 1 itself is a parent. Find 3. 3. Who is a parent? 1. Okay, here in an array 3, 1. Go to 1, minus 1. So the parent is same. So for both 1 and 3, parent is same. Both are parent are same. So it means they belong to same set and it's a cycle. If you include 1, 3, it will form a cycle. See, so far we included these edges, right? We have included these edges. And if we include 1, 3, this will form a cycle. So don't include this one. So that's how inclusion of any edge, will it form a cycle or not, we can know it with the help of this disjoint sets. I can continue like this. Okay, let me quickly finish the rest of them also. But here 5, 6 is gone. It is coming under this one. Now let us take next edge 6, 8. 6, 8. Find 6. 6 parent is 5, 5 parent is 1. So go here in the array. Let us see here also. 6 parent is 5 and 5's parent is 1 and 1's parent, that's 1 itself is the parent. So 1 is the parent of 6. Now what about 8? Find 8. In this graph you can see this graphically it is 7. So go to 8 and 7. Go to 7. It's minus 2. So this is the parent. So perform union on 1 on 7. Now who is greater? Minus 8 is greater. This is minus 2. So make this 7's parent as 1 and add 2 more nodes here and graphically show it like this. 7 and 8. That's it. Now the last one is 9th one. This is included. Now 9th one, if I try to include 5 and 7. Find 5, parent is 1. Find 7, parent is 1. Look at here, 5, 1 only. 7, 1 only. So for both of them, parent is 1. So inclusion of 9 will form a cycle. So this is how a simple array of values are sufficient for finding whether there is a cycle or not with the help of find and union operation. That's all with this. What just one thing is remaining here. See, instead of taking just minus 1, I was taking ranks or weight, and the union was performed based on whoever weight is higher, right? So this is weighted union. Now one more term is used, that is collapsing find. So let me tell you one thing here. See, if I say find 2, go to 2, 1, 1 is negative. Just 2 steps. Find 3, go to 3, 1. At 1, minus 8. So 1 is a parent. Just 2 steps, constant steps. Find 4, go to 4, go to 4. It will take you to 3, go to 3. It will take you to 1, then here. So the time is more, time is more. So here for some nodes the time may be more. You have to go along the parent and parent and parent, then finally you will get the root or the main parent of a set. So what we do in this situation is, when we find that parent of 6 is 5 and then its parent is 1, so finally parent of 6 is 1. So for this we have to take multiple steps. But once we found out that the parent of 6 is 1, we don't have to keep it there only. We can directly bring 6 under 1. So here also in 6, 5 is the parent, 5's parent is 1. So for 6 also it is 1. So we can directly modify this one. Now whenever we say find 6, go to index 6. What is find there? 1. So at 1 it is negative. So parent of 6 is 1. Directly in constant time we can know parent of any element. So this procedure of directly linking a node to the direct parent of a set is called as collapsing find. With collapsing find, we can reduce the time for finding the same value next time. First time we may be spending some extra time, but next time in constant time we can get the parent. Now same way, suppose I find 8, from 8 go to 7, from 7 go to 1. Let us do it here. Go to 8, 7. 7 it's 1. Go to 1 it's parent. So once we know that 8 is under 1, so directly bring it under 1. So here also we can write 1. So whenever you find any element, you can collapse it to its direct parent. So that's all how we can use array for representing disjoint sets. And even linked list can be used for doing this. So for linked list you can explore it. I have shown about array in detail, everything I have shown you. When we use linked list, then we have to take nodes, and in the node we have to write down these index. Instead of index, we have to keep it as a value, that is the node value, and a pointer to the parent, pointer to the next node. So you can explore that by yourself. That's all with the disjoint sets.